Greetings everyone. Myself Vivek and this is my teammate Suhas Bhat. We are presenting an experiential learning on electrocardiogram detection of R peaks and average heart rate calculation under the guidance of Dr. Anand Jatti sir. So basically, the ECG signal, which is the electrocardiogram signal, is the main element which is used in the medical field to monitor our health. So ECG signal usually mainly consists of P, Q, R, S, and T peaks. And here in our model, what we have done is detection of the R peaks is the main work that we are doing. This, as you can see, this is the raw signal that has been taken from the patient by inserting the ECG probes to his body or by placing ECG probes on his body. Steps for the detection of the R peaks is first to remove the low frequency component, that is by converting the time domain into the frequency domain, then removing the low frequency components and bringing back it into the time domain. Here what we are doing is the local maximums. The local maximum means, as you can see here, the R is the local maximum here. So by that principle we can detect the R peaks here. After detecting the local maximums, the removal of small values and storing the significant ones, and by adjusting the filter size, like for a certain duration we are adjusting the filter, and for in that certain certain band of signal, we are calculating the R peaks, and using that R peaks we are calculating the average heart rate of the patient. As you can see, this is the raw signal. Here what we have done is we have converted into frequency domain. From the frequency domain we have removed the low frequency components, and after after passing it through the rectangular window filter, you can see the local maximus here, and in this part you can see the low frequency components are being removed.
You are able to low frequency components by applying window technique.
Applying the window technique, and here finally the R peaks are detected. You can see the steps and steps like corresponding to the graph shown above. And this is the MATLAB code which were
after removing that low frequency component, will you losing any of the data?
No sir, the low frequency components are mainly due to errors in the probes or during the calculations or due to the movement or there are some electron movement that happens in our blood, that is mainly due to that, the low frequency.
Any variation in the wave pattern have you observed after your filtering?
No sir, we didn't collect the we did not collect the live samples. We got it from a net which is called as PhysioNet ATM bank. They upload the samples of like 1,000 patients for a month.
You can download the MAT file from there.
Correct, because in healthcare every bit of information is very important. Because based on that data, doctor will take necessary diagnostic plan.
Yeah,
If you lose the data, you will also going to miss the information about that pattern of.
But we are that low frequency, it appears only like minimum 10% of the time in a certain band. But what we are doing is we are calculating the average peaks. So it doesn't matter that much. It won't affect our calculations. The low frequency component.
There is no variations.
Okay.
So this is the MATLAB code.
Oh, what are main tools you have used in MATLAB? Main tool functions?
The filters we are using, FIR filters, and the window techniques, and there is a pre-built function which is called as you can see here the pre-built function you can see here, which is ECG demo window max.
Okay, you do it. Explain from beginning.
The code will be explained by my teammate Suhas Bhat.
So basically, first we are plotting the samples. We have got the samples.
Original signal pattern.
Okay. So we are plotting it. Plotting. So then we are applying the window technique to
Which particular technique?
rectangular window.
Why rectangular window?
So we get the one as like there is no variations.
Okay.
We can check the average easily. So we are finding the peaks here. Like R peaks we are find. Then you can for heart rate we are measuring like we are calculating the distance from first peak to last peak, and then taking the average, and we will get the heart rate. So that's the technique we are using.
R peak you are finding.
First we have to find the R peaks, Then
Okay.
we are taking the average of first and last R peak, so we get the
Total
heart rate,
number of,
average heart rate. So this is the code. So this is these are used for plotting the graphs. Like we have used 5 basic steps: applying window, applying sampling. So this is your plotting here. So when we run this code, we get 4.
What
We
are
have-
the intermediate results?
Intermediate
Original ECG.
Original
Original
ECG,
FFP
FFP filtered ECG.
Okay.
Then filtered ECG first phase. Then we are removing detected peaks. We are taking.
Here we are applying the rectangular.
You made inform magnitude, na? On what ground you made all inform magnitude? You removed any filtered, any...
Yeah, at low frequency components you are filtering using rectangular windows.
Okay. You have put any threshold for that?
No sir,
No, sir.
the threshold means the rectangular windows we are using from 0 to 1.
Mhm.
This is the rectangular window height.
Okay.
So basically this R peaks usually, if it is greater than 4, means 0.4, it is detected, the R peak is detected. If it is less, it is detected as a low frequency component and it is removed.
Okay.
So
Then after that, what else you've done here?
That is this is the detected peaks. This is the filtered ECG second pulse. That means if there are some more that's what you told sir. If there is we need more accuracy. Means
So filtering again and again.
filtering again by reducing the peak the height of the rectangular component. This filter window sir.
Okay. What is this other pattern here?
This is marginal ECG signals.
We are uploading 2 samples. This is sample 1 and this is
Sample one,
sample
sample
2.
two.
This is the stepwise graph for sample 2. This is stepwise graph for sample
So
1.
sample ECG and stepwise for sample. Here sample 2.
In what way these plots are useful for doctor for further diagnosis planning?
They can check the heart rate.
That is usually
Calculate
to calculate the heart rates.
Is there any earlier existing methods are there? What doctors are doing?
Like usually they use analog signal analysis, like the live signal analysis. They are not converting into digital samples.
In what way it is better than earlier method?
Sir, Bant.
In what way it is better than earlier one?
In the digital model, we are doing is removing the low frequency components. But in analog, due to the overlapping of the low frequency components, there might be error. This is not a 100% solution, but what we are mainly doing is removing the low frequency component so that it won't affect the R peaks in the calculation of the heart rate.
Main learning from your through this self-study?
Self-study is mainly the MATLAB code, how to load data from the library or how to use a particular function, and we have like learned more about the filters, like rectangular filter, and by testing with the Hamming window or rectangular window, we have seen that rectangular window is more optimal for the this particular application. We have came across this, and also we have studied about FIR filters.
What made you to select this particular application?
Like we are mainly interested to select in the biomedical. Wanted to see through the biomedical field because it is more helpful in for the society, and it is a real-time application. So and it is like the day-to-day thing that happens in hospitals. So we wanted that because ECG signal detection is the.
Also, you can think of applying Python for this.
Yes, sir, but what we have done is we have extracted the sample from a particular site, and that site was providing the samples using MAT file only. So we have written the code in MATLAB.
Okay, thank you.
Thanks.